Right, and this last one, which did baffle me a bit when I first read it, let's see if it makes more sense. Frankie is watching Ben from the top of an identical apartment building on the other side of the street. Frankie is at the same height, but 40 metres away. So there's my diagram there. So Frankie is standing up there. That is 40 metres. The phone has fallen 19.2 metres. Okay. For the wave that Ben hears is 416.2 hertz, which is the one we've just calculated. Calculate the frequency that Frankie would hear. Right, let's just think what's going on here. Okay, so Frankie's there. He's listening to the phone over there. So the waves are coming towards him like that. Now, the phone is falling, it's still moving away from Frankie. So the phone moves away from Frankie. Because we can see as it drops a little bit more, this distance is going to be greater than that distance. So I think the question is how much more quickly does it move away? So we want to know the component of the phone's velocity in direction away from Frankie. So if we draw that out more geometrically, so here's Frankie, here's Ben, here's the phone. The phone is moving that way at 19.4 meters per second. What we want to do is to resolve that into and find its component along this line here. So let's just extend that line there a bit. So what we want to know, component on there, so it's got to have a right angle to that one. So we want to know if that length is V, what is that length? Let's call that U, so what is U? And it doesn't look terribly straight here. Okay, what are my angles? Hopefully I've got enough information to work this out. So it's 40 metres along that way. It's 19.2 metres that way. Therefore, my angle in here I should be able to work out as the inverse tangent of that over that. So theta equals inverse tan of 40 over 19.2. That angle is going to be the same as that angle. Therefore, what I want is this cosine that angle. So U equals 19.4 cosine theta. When I have U, I can then use my Doppler formula, which I've just removed, in order to work out what Frankie would hear. And I'll leave that for you to calculate.